Slide a coffee cup across a table. Go ahead, do it in your head. It slides. It slows down. It stops. Boring, right? We see this every single day of our lives. You push something, and eventually the universe grabs it and says, stop. We call this friction. And if you ask a teacher why it stopped, they'll say, because the surfaces are rubbing together. And you'll nod, and you'll move on. Stop. Don't move on, because that answer is a lie. Rubbing is not a physical law. It's a lazy label we slap on a mystery we don't understand. Here is the truth that's going to keep you awake tonight. The cup never actually touched the table, not once. On an atomic level, there is always a gap of pure empty space. So, if the cup never touched the table, what stopped it? How can a force grab a moving object across a gap of nothingness and drain its energy? The answer isn't about roughness. It's not about grit. It is about the same force that lights up your house and cooks your food. We are about to dive into the quantum storm that rages under your fingertips every time you touch anything. Let me show you. Isaac Newton gave us one golden rule, the first law. An object in motion stays in motion unless acted upon by a force. So when you slide that coffee cup across your desk and it slows down and it finally stops, Newton says a force must be attacking it. We call it friction. And usually we stop asking questions right there. We treat friction like a magical brake pedal the universe presses. Oh, the surfaces are rough, you say. They rub, they grind, it stops. That's a cute answer, but it's lazy, and it hides the real mystery. Wait, think about the energy. When the cup is moving, it has kinetic energy, motion. When it stops, it has zero kinetic energy. Energy cannot be created or destroyed. It can only change forms. So where did the motion go? Did it vanish? Did the table eat it? People say, it turned into heat. Okay, but how? How does a forward motion turn into heat? What is the mechanism? Describing it isn't explaining it. Saying friction did it is like saying the car stopped because of brakes. It tells me what happened, not how the brake pads actually work. Here is where your intuition fails. You might think friction is just little bumps crashing into little bumps, like driving a Jeep over a rocky road. If that were true, then if I made a surface perfectly, atomically smooth, friction should disappear, right? The cup should slide forever, like a puck on infinite perfect ice. Wrong. If you make two pieces of metal perfectly smooth, I mean atomically flat, and slide them together, they don't slide forever. They actually screech to a halt. In some cases, they weld together instantly. So roughness isn't the answer. In fact, roughness is sometimes the only thing saving you from being glued to your chair right now. We need to go deeper. We are about to leave the world of things you can see. We are going down to the angstrom scale. Because the first thing you need to know about the contact between the cup and the table, it doesn't exist. Do this right now. Press your hands together. Push as hard as you can. You feel that pressure? You feel that skin-on-skin contact? That sensation is a biological lie. You have never touched anything in your entire life. Not your phone, not your food, not the person you love. You are hovering, always. Here is the thing. Everything you see is made of atoms, and atoms are weird structures. In the center you have the nucleus, positive charge. Surrounding it you have the electron cloud, negative charge. Now remember high school physics? Like charges repel. Negative pushes against negative. So when you bring your hand close to the table, the electrons in your skin atoms and the electrons in the table atoms start screaming at each other. Get back! Stay away! They push each other apart with the electromagnetic force. That touch you feel? That isn't contact. That is the feeling of magnetic repulsion. It's the same feeling when you try to push the north poles of two magnets together. You feel that invisible cushion? That is what you are sitting on right now. But wait, there is a gap. a literal gap of empty space about 1 nanometer wide. That doesn't sound like much, but to an atom, that is an ocean. If an atom were the size of a marble, you are hovering miles above the surface. So here is the paradox. If the atoms in the cup and the atoms in the table never actually crash into each other, how can they interact? How can the table stop the cup if it can't even touch it? Imagine 2 cars driving down the highway in parallel lanes. They never crash, they never touch bumpers, but suddenly one car slows down because of the other. How? We assume friction is a contact force, but if contact is an illusion, then friction must be something else entirely. It must be a force that can reach across the gap. People say friction is roughness, but if you're hovering over the surface, do the bumps even matter? Think about flying a plane over a mountain range. The mountains are rough, but the plane doesn't slow down because the ground is bumpy. It flies over them. So why doesn't your cup just fly over the atomic bumps of the table? Why does it get snagged? Let's look at the landscape. Because smooth is a lie too. Look at your phone screen. Go ahead. Wipe the fingerprints off. It looks like the smoothest thing in the world, doesn't it? To your eyes, sure. To your fingertips, absolutely. But let's put that screen under an electron microscope. Zoom in 100 times. It still looks flat. Zoom in 10,000 times. You start to see scratches. Zoom in 1,000,000 times. Stop. What you are looking at now is not a surface. It is a nightmare. It is a chaotic, jagged mountain range. Peaks the size of skyscrapers. Valleys deeper than the Grand Canyon. And that is on the smoothest glass you own. Now imagine the bottom of that coffee cup. It looks smooth too. But under the microscope, it's another mountain range, just upside down. So when you slide the cup across the table, you aren't sliding 2 flat surfaces. You are taking the Himalayas and dragging them upside down across the Rockies. Think about this scale. The peaks on these surfaces are thousands of atoms high. When you push the cup, these mountain ranges collide. The peaks smash into each other. They interlock. They grind. They literally weld together for a split second and then rip apart. Wait, this sounds violent. And it is. But remember what I said before? Atoms don't touch. So even though these mountain ranges are colliding, there is still that gap, that 1 nanometer gap where the electrons scream, "Get back!" So how can they crash if they can't touch? It's not a car crash, it's a magnetic field crash. It's like trying to push 2 strong magnets past each other. You feel the resistance even before they touch. But it's worse than that. Because atoms aren't hard little balls like marbles. They are squishy. They are weird. And when they get close, they do something that changes everything. They don't just repel, they stretch. You probably picture an atom like a solid ball, like a billiard ball on a pool table. If atoms were hard, they would just bounce off each other, ping, ping. And if they bounced perfectly, there would be no energy loss, no friction. Everything would slide forever. Wrong. Atoms are not hard. They are fuzzy. They are clouds. They are weirdly stretchy. Imagine every atom in your coffee cup is connected to its neighbors by invisible springs, and every atom in the table is connected to its neighbors by invisible springs. The whole universe is just a massive mattress of springs. Now, drive a Jeep over a mattress. What happens? The wheels sink in, the springs compress, the mattress pushes back. But it doesn't push back instantly. It takes energy to squish those springs down. And when the wheel moves forward, the springs snap back up behind it. This is exactly what happens when you slide your cup. The atoms on the bottom of the cup push down on the atoms of the table. The table atoms don't just sit there, they bend. They get squished. Their electron clouds get distorted. Wait, this is where the magic happens. It takes energy to bend those atomic springs. You provide that energy when you push the cup. But unlike a perfect spring that gives all the energy back, atoms are greedy. When the cup slides past the bump on the table atoms get shoved forward. They lean. They stretch like rubber bands being pulled. And then Snap. The cup moves on. The table atoms snap back into place. But here is the trick. When they snap back, they don't just return to their original spot and stop. They wobble. They vibrate. They jiggle like crazy, like plucking a guitar string. That snap is where the energy goes. You put energy in to stretch the spring, but when it snaps back, it doesn't push the cup forward. It just vibrates in place. So friction isn't just roughness. Friction is electromagnetic elasticity. It is millions of tiny atomic springs getting stretched and snapping back every second. And that snapping, that vibration, we have a name for that. We call it heat. But hold on, because this still doesn't explain how the motion stops. Just because the table vibrates doesn't mean the cup has to stop. Why does the cup lose its speed? Why doesn't it just keep going while the table vibrates? The answer is in the pluck, and it is absolutely mind-bending. This is the part nobody tells you. This is where friction actually happens. At the exact moment one atom plucks another. It's like running your fingers along a guitar string. Imagine the table is made of atoms connected by springs. When you slide the cup, the atoms on the bottom of the cup push past the atoms on the table. They deform. They lean. The table atoms lean forward, stretching their springs. But they don't want to lean. They want to snap back. Wait, think about that. When the cup is pushing the table atoms forward, it is doing work. It is putting energy into the springs, like stretching a rubber band. The energy is stored in the bent bonds. But eventually the cup atom moves past the table atom, and snap, the table atom springs back. It vibrates wildly. Where did that energy come from? It came from the cup. The cup lost kinetic energy. The table gained potential energy in the springs. And then, when the springs snapped, that potential energy turned into vibration. But here is the catch. The vibration is random. It's chaotic. The table atom is now jiggling like crazy in all directions. It's not pushing the cup forward anymore. The energy that was once organized motion is now disorganized motion. This is the mind-destroying part. Friction isn't a force that stops things. Friction is a process of theft. Every single time an atom on the cup slides past an atom on the table steals a tiny bit of energy. Billions of times a second. It plucks energy out of the cup's motion and turns it into a useless jiggle. It's like a tax. Every time you move, the universe takes a cut. And where does that tax go? It goes into the random, chaotic vibration of the atoms. So when the cup stops, the energy isn't gone. It's just hidden in the microscopic world. The table is now vibrating slightly faster than before. The cup is vibrating slightly faster than before. And that vibration is what we call heat. But wait, if heat is just vibrating atoms and friction creates heat, why can't we turn that heat back into motion? Why can't the vibrating table atoms push the cup forward again? Why does friction only work one way? Why does the cup stop but never spontaneously start moving again just because the table is hot? This question breaks physics, and the answer involves the most depressing law in the universe. So let's trace the crime scene. The cup was moving. It had kinetic energy. Then the cup stopped. It lost kinetic energy. And the table got warmer. The atoms started jiggling faster. Friction turned the cup's organized motion into the table's disorganized motion. Think about this. When you slide the cup, you are forcing trillions of atoms to move in one direction. The atoms of the cup all say, "Let's go that way," and they drag the table atoms with them for a nanosecond. But then, the table atoms snap back. They start vibrating up, down, left, right, forward, backward. They are now moving in every direction at once. Chaotic, random, messy. This is what we call heat. Heat isn't a fluid. It isn't a substance. Heat is just the kinetic energy of atoms that don't know where they are going. When you rub your hands together to warm them up, you aren't creating anything new. You are just taking the organized motion of your arms and turning it into the disorganized jiggling of your skin atoms. Wait, this seems simple, but let's calculate something. Where exactly did the energy go? If the cup weighs 200 grams and was moving at 1 meter per second, it had 0.1 joules of kinetic energy. When it stops, that 0.1 joules is now vibrating in the table. The table atoms are now jiggling slightly faster than before. But here is the sensory part. You can feel this. Slide your finger across the table really fast, like really fast. It feels warm, right? That warmth is the feeling of billions of atoms screaming. They are vibrating so violently against your skin that your nerves register it as heat. So friction isn't a brake. Friction is a blender. It takes the smooth directional flow of energy and shreds it into a billion tiny random pieces. It takes the organized river of motion and turns it into a chaotic ocean of noise. And once that energy is shredded, once it becomes random vibration, it is almost impossible to put back together. Think about this. If heat is just motion, and the table atoms are jiggling like crazy, why don't they ever push back? Why don't the vibrating atoms ever accidentally sync up and push the cup forward again? Why does a hot table never make a cup slide? The answer isn't about physics. It is about probability. It is about the second law of thermodynamics, and it is why time only flows in one direction. Here is the question. If friction converts motion into heat, and heat is just atoms jiggling, why can't the heat turn back into motion? Why don't the jiggling atoms ever push the cup forward again? Imagine a billiards table. You shoot the cue ball. It hits the rack. The balls scatter everywhere. That is friction. Organized motion turned into chaos. Now reverse the film. The balls all bounce off the cushions, reassemble into a perfect triangle, and shoot the cue ball back at you. That never happens in real life. Why? Not because it's physically impossible. Technically, if every single atom in the table happened to vibrate in the exact same direction at the exact same time, if they all pushed up and forward simultaneously, the cup would fly across the room, the table would cool down slightly, the cup would gain speed, energy would be conserved, everything would be fine. But wait, this never happens. Ever. Why? Because the odds are virtually zero. It is like flipping a coin 1 billion times and getting heads every single time. It is like shuffling a deck of cards and accidentally dealing a perfect royal flush to 4 people in a row. This is the second law of thermodynamics. Entropy always increases. Disorder always wins. Friction is the universe's way of saying, I prefer chaos. It takes organized energy, motion, and spreads it out into disorganized energy, heat. And once it is spread out, you can never gather it back perfectly. So friction isn't just a force. It is a one-way street. It is a process that destroys information. The information about which way the cup was moving is lost forever in the random jiggling of the table atoms. You can never unspill the milk. You can never unbreak the egg. And you can never unfriction the motion. But here is the twist. We have been talking about friction in air. What happens if we take away the air? What happens if we take away the impurities? What happens in the vacuum of space? The answer is a nightmare called cold welding. You think friction is annoying? Imagine a world without it. Or rather, imagine a world where the atoms don't just repel and slide. Imagine a world where they fuse. Instantly. This is called cold welding, and it is terrifying. If you take 2 pieces of metal, perfectly clean, perfectly smooth, and you touch them together in a vacuum, no air, no oxide layer, they don't just slide, they become one single piece of metal, instantly. The atoms don't know they are separate pieces. They think they are part of the same crystal lattice. They bond, electron clouds merge, and suddenly your spaceship door is welded shut forever. This actually happened in the early days of space exploration. The Galileo spacecraft, the high-gain antenna failed to deploy properly. Why? Because some of the pins cold welded together in the vacuum of space. The friction wasn't just resistance, it was fusion. The metal parts thought they were one solid block. Wait, Why doesn't this happen on Earth? Why don't your car keys weld to your ignition? Oxygen. Oxygen is the hero here. Every piece of metal on Earth is covered in a thin layer of rust, oxide. It forms instantly. You can't see it, but it acts like a microscopic lubricant. It prevents the raw metal atoms from touching. It keeps everything separate. So friction on Earth is actually surprisingly low because of the air we breathe. The oxygen acts as a buffer. Without it, everything metal would stick together like superglue. Your zipper would never open again. Your engine would seize instantly. Your silverware would become a solid block in the drawer. So, be grateful for that oxide layer. Be grateful for the dirt and the grime and the air, because without them, friction would become a welding torch. But what if we could turn it off completely? What if we could create a world with zero friction? It sounds like a dream. Perpetual motion machines, infinite sliding. But think again. Close your eyes. Imagine I snap my fingers and friction disappears. Everywhere. Instantly. Zero. What happens? You probably think of ice skating. You slide out of your chair. Cars spin out of control. Everyone falls down and laughs. It sounds fun, right? A giant slip and slide. Wrong. It is the apocalypse. Within seconds, civilization collapses. Why? Because everything you rely on is held together by friction. Look at your shoes. The knots are tied. Without friction, they untie instantly. Look at the screws in your desk. Without friction, they unscrew themselves. Look at the nails in your house. Without friction, they slide out of the wood. The roof collapses. The walls fall apart. Every knot, every screw, every nail, every woven fabric depends on friction to stay put. Your clothes would literally unravel off your body. The threads rely on friction to hold the weave together. Without it, you are standing naked in a pile of loose thread. But it gets worse. How do you walk? You push against the ground. Friction pushes back. Without friction, you can't take a step. You are stuck wherever you are standing right now, forever, or until gravity pulls you down a slope. And then you slide forever, until you hit something. And even then you bounce off perfectly. So a world without friction isn't a fun ice rink. It is a world where nothing stays together. It is a world where structure is impossible, where everything falls apart, where entropy wins instantly. So friction isn't the enemy. Friction is the glue. It is the only thing keeping your life from literally falling apart at the seams. So here we are. We started with a simple question. Why does friction stop motion? Why does the cup stop? And now we know. It is not about rubbing. It is not about bumps. It is about electromagnetic forces. It is about quantum springs snapping and vibrating. It is about the universe stealing your kinetic energy and turning it into heat. Think about this. Every time you take a step, you are borrowing friction from the ground. Every time you hold a pen, you are using friction to grip it. Every time you breathe, your diaphragm pushes against your lungs with friction. Without it, life as we know it would be impossible. So the next time you slide a cup across the table and it stops, don't just see a boring physics problem. See the trillions of invisible springs stretching and snapping. See the atoms vibrating like tiny guitars. Feel the heat being born under your fingertips. And remember that friction isn't just stopping you. It is holding you together. It is the handshake between you and the rest of the universe. It is the only reason you can touch anything at all. Leave you with this. The next time you feel frustrated that you can't push something heavy, or that your car uses too much gas, just remember, the alternative is a universe where everything falls apart, where nothing can ever truly stop, where silence is impossible, where peace doesn't exist. Maybe friction isn't the villain after all. Maybe it is the only thing keeping us grounded. Thanks for watching. If you want to understand more about the invisible forces that rule your life, hit that subscribe button. Let's keep exploring.